Hello, welcome back to the LOOC. In this segment we continue looking at the this reference and then we look at overloaded constructors. So returning to our previous example of simple time, there is a constructor there that has parameter names, and it could be local variable names as well, are the same as instance variable names, and as such they hide or shadow the actual instance variables, and in that case we use the this reference to refer to the hidden instance variables, and in case a member is not hidden, the this keyword is implied but can be included explicitly. So in our case it was an example of it was the simple time method, in which case the method parameters hour, minute, and second had the same name as the instance variables hour, minute, and second, and as a result, in writing the method, we had to distinguish the two by using the this reference. It's implied but not necessary. So, for example, in case of universal string, which is no input parameters and has no local variables that could hide the instance variables, so the this reference in this case is implied by can be put in there explicitly. It just makes the code maybe clearer. Generally, if there's a local variable with the same name, we need this variable, and in practice though it's better to avoid local variable or parameter names that are the same as field names, even though we can get around that using this reference. It can cause problems and hard to locate bugs, so generally it's not the best idea to do this, but in some cases might be absolutely necessary. So a comment on performance that C# reserves memory only for one copy of every method, and every instance makes a reference to that one method. However, each method has their own copy of the instance variables, that is the non-static variables, and whenever there's reference to that, this reference is implicitly used. Next, we look at the concept of overloaded constructors, similar to overloaded methods. Any kind of method can be overloaded. Instructors are no exception, and that allows client code to initialize an object in a number of different ways. These are constructors with different signatures. So in our case, there is a time2 class that is similar to the time that we looked at before. It has instance variables minute, hour, and second as before, and then constructors. However, in this case we have actually two constructors for time2, and they are different because they have different input parameters and therefore different signatures. Namely, the first one, as before, has three integers as parameters that are used to set the instance variables, actually by a call to set time. But in the second case, the constructor has one parameter that is used to initialize a new object, and as such will be a copy of our original object, and therefore this type of constructor is also known as a copy constructor. So here is the code again. The first and second constructors are different because they have different parameter lists. And the second one is a so-called copy constructor that creates an object out of another object of the same type. Set time is used to set the actual properties, in this case not even instance variables, because we have properties implemented that use those instance variables. Both of them have a get and set accessor and mutator pair, and the set uses input validation, so it checks the correct values for hour, for example, and throws an exception, in particular an argument out of range exception, and this time we specify the message that it will print, and the same for a property minute that is a public wrapper with a getter and setter for the lowercase minute instance variable, which is private, and the same for second. And then there is our universal time string format function as before, and there is our toString that overrides the classes, the object classes toString method. So there are three default parameters in the first constructor, and the second one uses is a copy constructor. It also has input parameters that initialize the class. So default parameters, so for hour, minute and second, all of them are 0. And those are used in case the parameters are not specified. So this constructor can be used without any parameter at all, in which case it will use hour, minute and second as 0. Or we can specify the first or the first two and not the last or the last two. So this constructor alone, because of its default parameters, allows three different ways to create a class with 0 arguments, 1 argument, 2 arguments, and 3 arguments, 4 ways actually. So this alone is an instructor that can be used in multiple ways, let alone there is another one that is overloaded. So this kind of initializer list sets default values within a constructor. So and as such it can be used as a parameterless constructor that has no arguments, also known as sometimes as the null constructor. Generally speaking, that a constructor can call other methods in the class, like in our case set time is being used by the constructor, but we have to be aware that the instance variables may not be set because the constructor is in the process of actually creating the variable, the object, and an object of a class can have reference to another object of the same class and has access to all of its data and methods, including private, because we are dealing with the same class. In our example, the constructor, the second constructor, has a reference to another instance of the same class, and it can access all the private variables, although in this case we are using the public properties actually. Generally we could change it to something else, like make it to the total number of seconds since midnight, and in that case only the bodies of methods have to change, but set time, universal string, and toString would have no changes because they call constructors that take care of this difference. and the get or set accessor inherits the access modifier of the one that precedes the property name. Generally, the class properties, the class private instance variable can be accessed by the methods of the class, and it's a good practice to set them private so that there are no errors by accessing, for example, without validity checking. So we are actually 6 different constructors that we can use actually in the test program. So there are 6 objects, and we invoke the constructors in a number of times with 0, 1, 2, and 3. So that's 4 different ways of how many parameters we pass in, and those that we didn't specify I all set to their default value, and there will be a 6 instance, T6, which will be initialized later, and then we print out all of these objects up to the first 5, and then we create a 6th one, this one with incorrect, invalid values, so all of them are incorrect, and therefore we throw an exception, and we specify particular operations in the catch block. One is exception while initializing a particular value, and then we type out the message. And the output will show the first object with all arguments defaulted, the second hour specified, minute and second defaulted, the third, only the second is defaulted because the hour and minute specified, the fourth or 3 are specified, so no default is used, and in case of T5, an object T4 is specified, so we use the copy constructor. And then the 6th one throws the exception when exception while initializing T6, and then the default message of the exception. So if you look at the code, then there are the various constructors, 2 different one, and the first has default values, and therefore it can be called a number of ways, and there is an hour, minute, and second property with setters and getters, and the setters do validity checking and throw exceptions when necessary, and then the output string converters, and then in the main method we create 6 instances. The first 4 uses the first constructor with 0, 1, 2, 3 parameters. The missing ones are defaulted. The 5th constructor uses the copy constructor, so it creates a new time to object from an existing one, so it in effect creates a copy of it, the copy constructor, and T6 will be the one that won't get constructed because invalid data are passed in. Actually it gets constructed, but not with those data, and then the outputs. So if we rebuild the solution, and then after it compiled we can run it. So Control F5, and here is our output. It's a little longer than before, so seen in its entirety will look like that, and constructed with the first one is all arguments defaulted because we used a parameterless constructor or null constructor and then the next few, increasingly more and more arguments are specified. In case of T5, we created a copy of object T4, so we see the output being the same, 12, 25, 42. And T6 is the one that threw an exception because incorrect values were passed in. So that's how we can overload constructors. A default constructor is created if a programmer doesn't write one. It will be a parameterless constructor, so at least one constructor is always there in every class. And in case there are constructors declared and we want to call a parameterless constructor, we have to provide one. It will be a syntax error if we don't do so. Composition is the coding ability that a class can have references to objects of other classes as its members. So in a way, an object has another object nested or embedded in it, so it's composed of its own instance variables as well as some that are not native types but of user-defined types. So one example will be an employee class that relies a date class object to specify the birthday and the hire day of a particular employee. One form of software reuses composition because we use another object within a given object, another type object. So here is the example. This is the first type, date. It has a month and day, private instance variables, and an auto-implemented property year, and then a constructor date where we specify the three input parameters for the month, the day, and the year, and then we print out a message so that we know that the constructor was done, and we pass into this object. Every object has a toString method, so something will be displayed. We implement properties, month for the first instance variable, day for the second. Both of them have input validation and true arguments if with appropriate messages if the arguments are incorrect. Same for month, it checks for and day, so month and day also checks for leap years, so it validates that the years are properly entered, and also makes a calculation to have the right number of days in every month, including February in case of a leap year. So, and as a toString method overrides the default, in which we simply print out the month, day, and year separated by slashes. So that's our date class. And then we create a second class, employee, that has instance variables of first name, last name, and two date, which are strings, but two instance variables, birth date and hire date, that are of type date. So they rely on the previously defined class. So here is the employee class. First name and last name are string properties with the getters and the private setter. Note that the getter is public because it inherits the access modifier of the property itself, but we change the setter to private, so the first name and last name cannot be set outside of the client code outside of the class. And then there are two date type properties, the birthday and the hire date for an employee, also has get and set properties. They are set being private. And the constructor initializes the employee out of these 4 parameters, 2 strings for first name and last name, and 2 dates, one for date of birth, one for date of hire, and we set them as any other type. So as an example of one class using as type another class that is a type that is used in here. And then a 2 string in which we display the last name, first name, and the hire date and the birth date of the employee. So in our test harness, we will create 2 date objects to represent an employee's birthday and hire date. So in employee test, the main method creates 2 date object, the birth and the hire date. And then when we create the new employee, Bob Blue, his birthday and hire day will be those previous birthdays. So he was hired quite a long time ago, and therefore he's been on the job for quite a bit. And when we display the employee, then we get the data properly displayed, including when we display the employee itself. So if we look at the code, then we see the employee object as in the slides. So that's not the right one that I'm looking for a second. This is the correct one. So the date class implements the date, including constructor, and it's the month and day properties, including checking for validity, leap years, and the like, and then the 2 string converter that prints a date. So this is one class within the project, and then other class is the employee class. And in the employee class, we have first name, last name, which are strings, but birthday and hire date are of type date. And when we create the employee in a constructor, then we set those, and that the employee has a string converter to string. And then the employee test class creates 2 dates for birthday and hire day, and an employee who uses those birth and hire dates, and then we display the employee itself. So if we try to build the program, then in case it successfully compiles, which has happened, we can test it out. So Ctrl F5 to test, and there it is, our employee Bob Blue with his hire and with birthday and hire day both displayed correctly. And again, the important aspect here is that in the employee class itself, we use date as a possible type of data for birthday and hire date, and an employee is created using those and then displayed properly. So that's that program, and I won't need these others too, but we'll need the third. A few comments about other facilities that C# has and provides. One of them is garbage collection, and the others is the use of destructors. And the common language runtime uses a garbage collector method that releases memory that are occupied by objects that are no longer in use. In other words, they're out of scope. And if we don't do this, then we would end up a resource leak, such as a memory leak when unused memory is still occupied by the program. And when there are no more references to an object, then it becomes eligible for destruction. And the garbage collector releases the memory associated with them. It's also called termination housekeeping. This kind of eligible for garbage collection means that the memory can be reclaimed by the garbage collector, and therefore memory leaks are less likely in C# than languages like C or C++, although in subtle ways this can still happen. Another resource leak when a file is left open by mistake, even though the object that opened it is no longer in use. And garbage collectors take care of all these issues. However, there is no set time when during the run of the program happens, and we don't have control over that. And a destructor is a form of method that does this release, but it just marks an object as ready to eligible for garbage collection. There's a close and dispose methods that, unlike the use of destructors by garbage collection, force the memory leak, the memory release, and close file streams that are associated with the object. Next we look at static class members or static variables as opposed to instance variables. And a static variable is one in which there is only one copy for the entire class, and therefore they are shared by all instances of the class. So it's a class-wide information, and the keyword static declares them. And they are used when all instances have to use the same copy. The scope of it is the body of the class. It can be public, and therefore can be accessed in client code, such as the math class has a static public member pi, the value of the number pi, but static variables can be private, and then only the class can have access to that. Static members exist as long as the class is loaded into memory, so even when there's no instance of the class, and they can be private or public. And static members cannot be invoked by methods that are specific to objects, so only a static method can access a static variable of a class, and they can be used even when there are no objects created, because they are associated with the class as a whole, not with individual instances. So the second employee program uses a private static variable for count, and the associated property, capital count, which counts the number of objects that are created of this class. This is one classic use of static fields, variables and properties, when we need to keep track of how many objects have been created by constructors of a class. It's a little bit like a factory keeping track, like a car factory keeping track of how many cars they ever made. In a test program we use 2 employees. So here is the class employee, and first up is a public static integer property count as a get and set private setter, and read-only auto-implemented property first name. It's read-only because its setter is private, and the same for the last name. And here is the constructor, and the way the count variable gets used, that every time the constructor is called, it is incremented by 1. and we are displaying the workings of the constructor by specifying how many, not just the name of the employee, but how many have been created. And as always, the count property and the underlying instance static variable, if not set, they were defaulted to 0. So when we start creating objects, the plus count will increment the count every single time a new employee is created. So in our test harness, we write that employees before in instantiation and the count, which should be 0 before we create any instances. Then we create 2, Susan Baker and Bob Blue, 2 employees, and we display the count after that, and as well as the actual employees. And when the employees are no longer needed, then we can set the references to them to null, which is good practice because this will mark the object as eligible for garbage collection. And that is the output. So initially there are 0 number of employees, and then we create 2, so 1 and 2 will be the counts, and after instantiation the count is 2, and then we display the 2 employees. So if we look at this program, then here is the class employee with the public static integer variable count, and auto implemented first and last name with read only, so private setter, and then the employee constructor. And the crucial aspect of it is that every time a new employee is created, the count is incremented by the constructor to keep track of the employees. So that has to be there if we want it to be correct. And the employee test is the test harness that creates 2 employees, prints out their numbers, which is 0 before any is created. Then we display after, which will be 2, and then we display the 2 employees, and then mark them as eligible for garbage collection by setting them to null. So if I rebuild the solution, then as soon as it compiled, we are ready to test. Control F5, and there they come. So we see that the number is 0 before. Just moving the output window here out of the way. So before any employee is created, the number of them is 0. And when we create the first employee, Susan Baker, the count will become 1. And when we create the second employee, Bob Blue, the count becomes 2. So the total number of instances created of this class employees after the instantiation is 2. We display the 2 employees, and then we delete them by setting them to null, and that's the end of the program. So that's how static class members work. A few comments: that strings are immutable, and therefore it's safe to have any number of references. When we concatenate a new string object created and the originals are still there, immutable, unchanged, there is garbage collector, but it's not guaranteed when or whether it will run, and maybe only some of the objects will be release the memory, not all. Static members cannot access directly non-static, that is instance variables, because they are available even when no objects are yet or at all created by constructors, and this reference cannot be used in a static method for obvious reasons, because no instances are needed for static methods and there may not be any, so that this reference would be meaningless. There's a read-only type of instance variable that indicates that an object is not modifiable, but it's not the same as constant, because a read-only variable can be initialized later, not when they are initialized, unlike constants, but once they are set once, they cannot be changed. And this works with the principle of least privilege, which says that the amount of privilege and access needed to accomplish a task should be granted to any client code, but no more. And if a variable should not be modified, then we can set it to read only as an example of that. It doesn't become unmodifiable until the constructor completes the execution, so it can change, for example, by the constructor, but not after that. It can be initialized at execution time, unlike constants that are can be assigned only at compile time. Typo there, and they can also be initialized with expression that themselves are not constants, arrays or a method call. Read-only helps to enforce the principle of least privilege, because if a variable should not be modified, then read-only prevents that. A class always, if there are multiple constructors, everyone should initialize a read-only variable, and we get a warning if it's not initialized and gets defaulted. And it's a compilation error to try to modify it, because it's read-only. And that is generally a good thing, because we want to catch errors at compile time, not at runtime, because runtime execution time, it might be in the hands of a client, so a client of the company for whom we are developing the code, so it's better to catch errors at compile time. If a read-only variable is a constant, then a constant should be used, not a read-only. So if it doesn't vary by instances, but the same for the whole class, then there's no need to carry separate instances in every object. So it shouldn't be read-only, but it should be a constant, and they are implicitly static, so only one copy is created, and that saves memory. The concept of information hiding and data abstraction is the fact that we hide the implementation detail from client code. Client code generally doesn't care about how a functionality is implemented, only what it is. A concept called data abstraction, and generally, even if we know the implementation details of a class, we shouldn't write implementation detail dependent code. And like all object-oriented programming, the importance of data is emphasized, and the creation of types, new types that are not built-in native types, is the essence of object-oriented programming. An ADT, an abstract data type, provides ways to create new data types for the programmers, and the representation of some real-life concept with some level of precision. And an ADT consists of two types, two parts, basically the data representation and the operations that can be performed on that. and classes are used to create abstract data type. So new types can be added, but the language cannot be modified by code. An example of it is a queue in which clients place an item via an in-queue operation and take them out via a dequeue operation, and a queue is a first in first out FIFO data structure. And the implementation of that and its internal data is close to client code. The class view and the object browser allows us to look at class and object structures, and object initializer allow to initialize object without passing values to constructors, but put it in a comma separated list in curly braces after the new keyword. And that's the end of this segment.